Okay, we're going to be covering 4-pin relays. Pretty simple once you get a good understanding of it, but some people have a hard time really grasping what's going on in the 4-pin relay. It's basically nothing more than a switch that we use electricity to control. Instead of us having to push a switch, we use electricity to actually switch the switch for us. That allows us to use just a little bit of power to control possibly a lot of power for a different side of the circuit. So I'm going to draw it out for you and explain it. We have our main relay box. We have wires going into our relay and coming out of our relay. Inside the relay here we have a coil. As we energize this coil, it creates a magnetic field which draws our switch in and closes our switch. So the internal part looks like this with a switch, which would pull over and hit that contact. Now coming in the relay, we have pin 85, we have pin 86. Over on this side, we have 30, and we have 87. So we supply power, or positive, to 85, and we supply ground, or negative, to pin 86. That energizes our coil. When the coil energizes, that switches, this switch closed. Now we have battery power over here. Our switch closes, so it's going to move from here to here, allowing our battery positive to come out on 87. We could send that to say a light bulb, a motor, anything along those lines, to light up our light bulb or start our motor. And that is the way it works. So there's a couple of known variables that you have here. Pin 85 or 86 should have power or ground. They can be interchangeable. 30 is always going to be a battery feed. And 87, if you're checking it disconnected and everything, it shouldn't have anything on it. It's only going to have power going to it when the switch is actually activated by the coil powering up. And that's a 4-pin relay.